everybody. Hello. It's the Monday stream. Running late because I have a whole bunch of things going on, but oh, hey Lorenzo. But I'm going to see whether I can do what I said I was going to do and code Nikola. So we'll see how that goes, and I'm probably going to go until 1 in the afternoon. Might run a little short, feeling a little too much going on these days. So on that note, let's migrate over to the programming computer, which I have to drag the thing over so the mouse will work, because the mouse can't see my black desktop. Oh, I have got some other things going on too. I'm inventing a nice way of storing the electronic parts I want to get. And here's an example. This is from a oat creamer that you can get, Califia, I think. I'm a big fan of the unsweetened oat creamer. It's better for a number of things. It's better than dairy stuff, and oats are better than almonds as far as a crop being grown in large quantities. But it's also delicious stuff, so I make chai tea with this sometimes. And this here is a container for ultra bright red LEDs. I'm going to need to get a goodly number of these, because when we start doing the hardware club stuff, this is not really suitable to have as display lights on the surface of your synthesizer that you build, but this is what you'd use for coupling with CDS cells, which is cadmium sulfide cells, which is photocells, which is part of what they call a Vactrol. So with a one of these and maybe some diodes, which I'm going to need to get a large quantity of those too, and a CDS cell or multiple ones, you can make Vactrols, meaning that you can do a bunch of electronic stuff that's very handy. And these are so insanely bright that they will drive the Vactrol to really low resistances by just blinding the thing. And it also gives you flexibility as far as what you might do with it. So, not a display light because it's simply too bright, but a useful tool. And if you get them in large enough quantities, they're like maybe 17 cents each or something like that. Whereas this one is red LEDs. And I was thinking about making people guess how many are in the container. I can buy them by the thousand. And these are about 7 cents. But this is the real prize. This is a container full of 2-cent LEDs. And if I calculate it out properly, what I can do is sell them by weight. I have this little scale in my kitchen that I portion stuff out with, and I can weigh LEDs on the little scale and be like, okay, an ounce of LEDs is $4 or whatever, because they are 2 cents, 2 pennies each. And with enough of these, you can use these as indicator lights. And rather than force people to guess, I can straight up tell you, this is 1,000 red LEDs. And this is actually 1,100. And this is 2,000 yellow LEDs. And you can get these from All Electronics too, but it just starts adding up if you're getting them by the 1,000. And you wouldn't need to do that right off if you were just building some kind of kit, building something cool for yourself. You wouldn't need the full quantities, but I feel it's a good idea to let people have access to stuff in these sort of bulk quantities. But anyway, enough about that. Let me fool with the OBS and got my little cute picture-in-picture there. And we're going to do Nikola. What you see is not Nikola. This is bass amp. And what I had last week was testing this out and showing it. I don't have better speakers or anything. I haven't got that together yet. I have been working on the music setup in hopes of maybe firing that up this Thursday. And I'll see whether that happens. But I had it running and I was pretty happy with what I was getting, and I was pretty happy with my ability to like turn on various instruments and things. Like I have my Rhodes running through a compressor now, which brings it up to a comparable level of this aux box and various other things that are driven by a sequencer, blah, 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 etc., etc. It's funny because it's like I want to do that, and at the same time, I know that people don't really want me to be doing it, but whatever, I want to do it. And here is bass amp from last week. I'll figure out how I can get this mouse comfortable to work with. And this is what my work is going to look like when I'm porting it to VST. Because what I have to do is take all these bits. It's a relatively complicated plugin. So we've got controls here, and then I copy this over from the other one, and I have to double all of these into left and right channels. This stuff was fairly straightforward, except for I haven't updated it yet. I have a process where I start removing like part of the, oh, it's not even on screen properly. I start removing the parts that I don't need so that I can work with the template, and I haven't even begun to do that yet, so I'm not going to worry about it right now. Instead, it's time to see what I've got with Nikola. And here's the thing. This is this little plugin, and oh, and I have not ported it yet. Awesome sauce. Okay, so we're going to do this live from scratch. This part is fairly easy though, because, and if I'm not making a lot of sense talking to you, I guess I kind of exhausted myself doing the triple spread plugin and the many previous plugins that I've done. And this is only the second time that I've tried coding stuff on stream. We could switch over and I can just answer questions. Like if you start throwing questions at me, I can switch right over to that and abandon this. But it is one of the things I promised. And what I'm wondering now is, do I even have a working version up? Fire up the old Dragons album. And do I have a copy of Nikola that hasn't been ported yet? We'll find out. Nope. So we're going to do this essentially from scratch. Not really from scratch because it exists in an older form, and I'm bringing it into the oh, and I seem to have updated it, and that I now have the subtype there. So what I'm going to do is go into this and find my old version. Ghosts does have a question. What would you recommend for a total noob programmer who wants to get into coding? Have a computer and be ready to use it? I really don't know. It's funny because pretty much I got very distracted this morning because I was making this. I have been working on the versions of Biquad, and the week before last week, I sound pathetic today. The week before last week, I did Biquad double, which is two instances of Biquad after each other. It's essentially a stacked Biquad filter. And here's the thing, is you can totally do that. However, if you were stacking Biquad filters to do particular things, turns out it's a known technique that I stumbled across today for stacking biquads to get multiple order filters to alter the Q factors. As near as I can tell, here's how it works, is you have them set up with the same type of filter, and they're the same cutoff frequency. But let's say, for instance, we're doing a fourth order Butterworth filter, and that's using two consecutive biquad filters. So the first one's going to be 0.54119610, and the second one's going to be 1.30656296. Whereas if you were just using a single one to do a Butterworth filter, the number you want there is 0.7071068. So when you stack them up, apparently what you do is you spread the Q factors. One's a little bit wider and one's a little bit narrower. And the one that is narrower is more resonant and will make hotter resonant peaks on the output, although Butterworth is about not actually being resonant. So that one goes to a number of 1.3. And I guess it interacts with the previous one, which was like 1.5. And further, I was digging through this all morning long. Bessel filter in a single instance wants to be 0.5773502. That's better for transient stuff. But Butterworth is the one that's a little bit steeper than that, but doesn't have any waviness or resonant peak. And if you go to a 1.0 Q factor, that's a Chebyshev filter, the first instance of a Chebyshev filter. Also, you can do one called a Linkwitz-Riley, which is 0.49. And I was looking into what you could do with the golden ratio. Have a 0.618 Q factor. What does that do? Because it's between Butterworth and Bessel. Turns out I have a plugin in the pipeline that is meant to be a triple biquad. And there is a form of, I think it's a form of Butterworth filter, but it's a form of fifth order Butterworth filter. And the Q factors for that starts off with a Q factor of 0.5. And in the second instance of the biquad filter, same cutoff, same frequency, but it's 0.618. And then the third one is 1.618, which of course is the inverse that you run into that also using golden ratio. So I'm like, hey, fifth order 3-stage Butterworth filter naturally goes to what appears to be a natural occurrence of the golden ratio. So now I'm all hopped up about trying that, but it means I'm going to have to recode the filter that's supposed to come out next week, the triple, and probably remove the Q factor, because it's like we're replacing adjusting the Q factor with stacking these up, and I'm probably going to want to refactor how, refactor means something different from Q factor. to take advantage of this way that you can use these special numbers for Q, meaning quality, meaning resonance, to get particular effects. It's apparently a well-known thing. I just stumbled across it this morning because I'm not the maths. You recommend for the total noob programmer, if you got into heavy math in school and learned all your calculus and stuff, you'd probably have a head start with me in certain ways, except for that I think people who do all the learning of the maths stop listening and they start thinking all the time rather than listening to what stuff is going to do. Like it's said that the Moog filter was arrived at through experimenting and getting things to sound right, and then they sort of filled in the details later. What I'm looking at is various different Q factors regarding, Butterworth and Bessel and so on and so forth. But it's fascinating now looking at some of these things. Like you can do a 0.5 by itself, that is a solid key filter cutoff, which basically means it's kind of slow. It rolls off slowly. And I stumbled across somebody else talking about a Legendre or something along those lines. And that is, I think, maybe slightly steeper than, well, maybe not slightly steeper than Chebyshev, but these all have their little distinctions. Like the Bessel filter is supposed to be really good at transients and handling that cleanly without extra energy or anything funny going on, but it rolls off really slow. Butterworth is the one that rolls off as fast as it can without adding a resonant boost. Legendre rolls off even faster, and the deal with it is, unlike the Chebyshev, unlike straight up turning up the resonance so that it sounds like a synthesizer filter, the Legendre rolls off even faster, and there's ripples on the output of the filter, but they only go down. They never spike up into a resonant boost. So instead of being a clean roll-off, the Legendre rolls off even faster, and it sort of dips and then dips more. And it always just flattens out rather than going into a boost. So that's another interesting form of filter thing. And lastly, I ran across a neat little development. You can have fourth order Butterworth filters, which is 2 biquads in a row, and you can tell them to be like the first is 0.54, 119610, etc. Second being 1.3 or whatever. But if you cascade 2 of these, like 0.54 and then 1.30 and then another 0.54 and another 1.30, you produce a 8th order Linkwitz-Riley 48 dB per octave filter. And that sounds like isolator material to me. That sounds like you could make it into a plugin, leave all the Q factor stuff out or leave everything out so that it's just a single frequency control, and do that sort of house music, dropping the frequency down until everything is very muted and bringing it back up again. And it's a really steep cutoff. It's a 48 dB per octave cutoff without resonance. So that seems interesting to me. And that would be like biquad 4. That would be biquad quadruple, except for I'll probably end up calling them by their actual names. Like call it Riley because it's Linkwitz-Riley, or call it isolator because that's what it would do. So I was all about learning about this stuff this morning, which is why I bogged down and didn't get streaming as fast as I could. I got behind. Let me have a look at the chat while we're live chatting. I'm not really sure what pure data is, so I can't talk about that. Oh, it's an audio language like C sound? That's fair. Yeah, LQ2 interestingly, that's what I'm talking about. When I say that I've discovered this fancy filter that's like an isolator, and it's a Linquence-Riley 48 dB per octave, cascading 2 fourth order Butterworth, you are also cascading 2 fourth order Butterworth. They're just not configured properly. Instead, well, they may not be configured properly. I don't know what your Q factor is, because that's the thing, is you can put the 2 biquad double instances on, and they can be a brick wall filter if you want to treat it like a brick wall filter. You're going to want to have the filter be like a Butterworth setting, namely 0.7071068, or as close as you can get, in order to have it not be resonant. I mean, you can steepen it all you want by making it higher than that, but it'll cause a resonant peak. And if you're trying to avoid that, trying to have a scientifically clean filter that doesn't do extra stuff, then there's only so many settings you can use, and using biquad double is not actually optimal, near as I can tell. You're supposed to use a lower resonance on the first one inside the plugin and a higher resonance on the second, and I did not know this when I made it, so I'll be revisiting some of those things and figuring out what to do with them. Although I'm probably not I'm going to be leaving biquad double the way it is, because it has the Q control in it, so you can crank up the resonance and it's just going to react in a predictable way. Maybe I should even do that with the triple filter that I have on hand and able to post. I could have that also behaving the same way, and you'd be able to crank up the resonance or crank it down or whatever. Might be worth doing, in which case I wouldn't actually be recoding that. I'd basically be going in and working variations on it that have these very specific identities that I was learning about this morning. I swear to you, I was up at 4 o'clock in the morning. I don't sleep very well lately. And programming the resonances to be these very specific numbers. And I'm particularly excited about the fifth order Butterworth that has the second and third resonances as variations on the golden ratio. That thrills me. I'm like, I bet that sounds cool, because that's going to be doing something interesting that echoes all throughout science. Golden ratio pops up. So I bet that's going to have, I can call it the golden filter or something. Further questions? This is not coffee, more's the pity. This is herbal tea. Fair amount of time. I just got to settle down. Stuff that I'm working on is demanding at times. I'm happy that I can come out with cool things, though. Like the triple spread plugin, I feel worked out well. I think that's going to have usefulness for people. So oversampling to avoid aliasing and saturation plugins. Well, I intend to try to do a form of oversampling, and that's what this note is about. Let's see. Actually, no, this note is a new console version. Hey, but there's this infinite pile of things that I must do. That's coming. I'm not telling you anything about that yet. But, oh no, wait. I put that aside. The resample idea is what I had on this note, where I need to come up with a way to, in the downsample, essentially do some clean methods of averaging the oversampling. I don't want to run the demanding complicated sync interpolation or whatever, because essentially my feeling about oversampling is you can't do good enough sample rate conversion to really get away with doing it properly. So you're always using bad sample rate conversion, and bad sample rate conversion sounds bad. So the only advantage you get is dealing with the aliasing to more of an extent. So I'm going to try to work out some kind of system where I can oversample, do the distortion calculation, and then downsample in a very primitive way. Downsample in a way where, like, it's going to be a sort of 2:3 ratio kind of deal, where I'll be generating 2 interpolated samples. So it'll be like 3 times oversampling, but it will be calibrated in such a way that I can get the output result by taking the 2 that are not the raw sample and straight up adding them together and averaging them, and then adding that to and averaging it with the raw sample, which of course is what I like to call word length shift gain. And in that way, I'd be able to do this calculation while leaving sort of the mantissa of the initial sample as untouched as I can get it. And that is a calculation that nobody considers because it's sort of strange Airwindows Mojo type stuff. It's along the same lines of dithering to floating point. I just feel that if I can do a simple sort of 3 times oversampling that works out in such a way that it gives a correct output, it gives a correct sound, it'll be a pretty good compromise between the whole trouble of doing serious oversampling and, because like consider some of the things like, I don't know, Kazarog K-Clep or whatever. That is doing very proper oversampling. I think you can go like 128 or 256x oversampling. That means every sample that you do, let's say you're running 96K, every sample that you're doing, you have to do 128 times the work. It's like running 128 plugins, except for not quite as bad as that because you're doing it within the plugin, so you're doing it within the buffer. But it gets to where you can't do anything really interesting or useful. Like one of the reasons you can do that with a clipper is because clipping is very primitive. I'm doing stuff like transcendental functions like sines and arcsines, and those are not nearly as cheap as clipping is. So if you take a plugin like Density or Console Channel or something like that that is doing a sine calculation, and you go, oh, I know what to do, we'll just do 128. Well, great. Say you're doing 16 tracks. Your 16 tracks, let me grab my calculator. You're doing 120 oversampling, so your 16 tracks are the computational equivalent of 2048 tracks, and you can't do your mix anymore because it doesn't run. So massive oversampling is the way to cleanly clip in primitive forms of clipping. But when you start doing sophisticated algorithms, it starts adding up and getting really messy. And that's why I'm going to try to do a 3 times version. And granted, 3 times is odd, but it's because I have that particular idea of I want 2 interpolated ones that are being interpolated in an interesting way. And then I want those 2 interpolated ones, and I'm probably going to have to run either 1 or 2 samples of latency as well, but I'll just do that. And then the 2 interpolated samples will get straight up averaged together, and the result of that will straight up get averaged with the raw sample, meaning that the raw sample is going to be 50% of the output. And it ought to be able to do some good against aliasing while still not being a very serious form of aliasing. But the idea is it's a form of oversampling that you can do very cleanly at 96K or up that will further enhance your ability to resist aliasing, run at these high sample rates and high track counts, and also run in such a way that it's not just grinding all of the samples into sort of digital dust, by doing these fine mathematical calculations. I'd rather do it sort of like bit shift style things. Oh, I should have called it word length shift. Now YouTube thinks that I'm swearing. Okay, so chat, yeah. New console, yay. Yeah, I'm pretty excited. Basically, I was talking with somebody on a chat and realized that the way console works is a little backwards when you violate its principles. When you use the faders to adjust console, it does the opposite of what you want. Instead of having channels get a little bit fatter and more saturated and more forward, if you push the fader, which you're not supposed to do because it's console, but if you push the fader up, it'll get more expanded. If you pull the fader back, it will get more distorted. And I know that small changes in that are also kind of forward and backwards motions in the soundstage. So it occurred to me, why don't I just build that in? And you still don't touch the faders, but that's because console channel will begin boosting twice as much or to some extent more than expected when you adjust it, but then the output will trim the opposite way, causing the end result to act like if you push it slightly, it gets a little bit more fat and thick. If you pull it back slightly, it gets a little bit more thin and falls back and makes more space. And I feel that I can make mixing with sliders or control surfaces or whatever much more natural doing this, but not in a way of emulating somebody's circuitry so much as just emulating a kind of thing that could be happening in analog gear. So yeah, that is that concept. And yeah, if I can get the oversampling thing working in a way that I like, that's also part of the concept, is it's going to do this adjusting so that it is more flexible. And that would mean that you'd have to use the control on the console channel to do that. So I'm thinking in lines of also making it like a channel strip and including some of the stuff that you're going to want. Maybe some EQ or something. But it would also be a test bed for whether the resampling idea sounds good or not, because that's the thing. Console is very clean. Console is capable of processing and then unprocessing stuff so that if a single sound goes through the console system, it will be unaltered, except for if you're driving such high frequency sounds into the console system that they're aliasing. And if they do that, they won't do it much because you're only producing maximum of, in fact, I'm not sure you can even do it within distortion, but it's only going to produce one harmonic basically because it's such a rounded overdrive. But if that is beyond the Nyquist frequency, it will alias back down. It's just very quiet when it does it. So I may be able to improve things doing that. Ahmed, as far as a plugin for fake double takes, I would say that Glitch Shifter is your man there. There's nothing else really I can do with that. Yeah, Lorenzo, then you want oversampling in every plugin. Well, you don't get oversampling in every plugin because it doesn't relate to some of the plugins. It relates to stuff that is changing amplitudes or transfer functions. And I don't think it applies to EQs so much. Unless the EQs have distortions built into them, which sometimes they do. So yeah, I guess folks are looking for Bose stuff. So let's start fooling with Nikola. I said I was going to. See, we've got a version here, and I've already copied the name over, so got that much going. I think maybe I'll put the old version over where it's behind chat and you can't see it. close this, and this is the version I'm building in. So go here. And I'm going to want to start by copying over. This is what my template looks like. It's got all these parameters so that I can just sort of build stuff up. Here's another thing for if you're starting to code and things that you might do. And this is contained within my templates, which you can still download from the GitHub. Bo, where do you think I should move the mic to? Is it when I'm sitting over here, I'm pointing in the wrong direction compared to when I'm pointing here? I can't move the mic without obscuring the camera. I'll figure something out. So let's see. Here is what the original Nikola looks like. We're just going to use this straight up. If I need to change it, well, I do have compression on. I'll turn my gain up. That way I can compress really hard like this, but also it'll pick it up a little bit more when I'm off mic. I'm trying to code. I can't really code with my head turned over here. So let's see. Typically what I do is I copy this bit. See how I've selected bits between Nikola parameters and Nikola? That doesn't contain anything named the plugins, so I can take stuff from different plugins and sort of mix and match them, get them rolling. There are people who will make great fun of you for doing that. You're not supposed to copy code from one place to another place, and you're especially not supposed to copy code from like Stack Exchange. And the reason I do stuff like that is because I'm getting off and running with something. And in this case, I'm not particularly worried about changing this around. This is going to be what it originally was to start off with. So let's see. Older one. I have told this one to have a tail time of 40. I do not know why. And a latency of 1 sample. However, I'm not concerned with that, partly because the VSTs I don't get to declare latency with. Here's my private variables. This is a world in the audio unit where you keep sort of global stuff that needs to continue to persist between buffers. Like if you're having the sound chase where the sample is, and it's chasing it very, very slowly, it's going to be like a really low frequency low pass, a really low frequency IR low pass. You'll have a number in here in the header file, and it says it's in public class, it's in the kernel AU effect base. Basically, it's what runs. And private means in this type of plugin, we have this integer called frame number, and frame number just kind of stays. You reset it in a separate place, and it just kind of stays around. If you've dragged it to some particular thing or you set it to something and then you process several other buffers and come back to it, it's going to be the same as you left it. Same with bool was negative. Bool means Boolean, that's a true or a false. C also lets you behave as if it is a number. Like if frame number is similar to if frame number equals 0, C does not do type checking very well. And I have a 64-bit floating point number, which is out level. I don't really know why I'm using that, but we'll find out when I put the code in. And the one that was there before, unsigned integer 32 _t, FPD, that is my dither number. That is what I'm using for the floating point dithering and preventing denormalized numbers. Now we'll open this up. We'll see that the template is filling in the time. Like this was a 07 plugin, but this is 111.120. So I built this template back in January, back before the world changed. And this is as far as I've got to it. You can see that these are no longer highlighted in blue. This version of Xcode highlights stuff in blue when it's a real constant number that's been declared, so these don't count anymore. I got to remember to leave those out, and I'm going to quickly look over into the earlier one and see that it's telling, and let me have a glance at the chat while we're at it. Yeah, I don't know much about Faust. I think iPlug 2 might be the plugin framework that I took an interest in a while back, though I was not good enough to be able to actually get anything out of it. But I think I might be helping the guy's Patreon. I might be supporting the guy a little bit. And Drake, you're not trying to derail the topic, but you're excited for the hardware stuff, so am I. That's why I'm compiling these things. My collection of tiny little LEDs. So what is Nikola? I'll show you once I get it working. The idea is it is like a Tesla coil that plays music. You might have heard the Tesla coil playing music at some point, and they're very loud and it's a very spectacular thing. It's music by lightning. This does not really sound like that, but I did the best that I could in 2007, and we haven't really gone any farther. So let's see. This is a generic parameter, so it's a floating point number, 0 to 1. So this is perfectly normal. This is exactly the same as we have here, except for I had room for 10. So I'm going to select all of these up to where it says default and delete them because I only need one. And now I don't have much in the way of reset here yet, so what I'm going to do is copy these from here because this is how this is supposed to go. Add them to here, and pretty soon we'll see what I actually am doing with this. And I'm going to do a little bit of refactoring while I'm at it because some of this is not done properly. Like we'll copy this and it goes here. This did not have a purpose, and these do. This is all to be able to run the thing sort of immediately. Even though it doesn't do anything, I've got it set up so that you can build it. And this is left over in the template, but it doesn't do anything. And these are all just numbers from 0 to 1. And all it does, it assigns these all to each other because otherwise it'll complain. It'll say unused variable, slider 6. So if I do this, it's like, oh, we've used all these, cool. It isn't doing anything useful with them, but it's fooling the compiler. And we're creating a thing and applying gain. And we have a wet control in here too, which does actually function. But we're not going to worry about that for the moment, although I might comment it out and leave it. And that's all there is here. Because this is the template, there's nothing here yet. So what we're going to do, I don't believe I'm going to be using overall scale, but So this is what refactoring is like. I'm already defining this down here. And back in the day, I used to say register for stuff if I felt that they were being used often. That is not useful. That hasn't been useful since like the 286 or something. So this was foolishness on my part back in 2007. We're going to ignore it. A bunch of these other things are not useful being set up here. We also don't need overall scale, except for I'm not sure whether maybe we're going to use it anyway. And this is the only bit that we're really going to use. And this, we end up not using this either because you know what? It is more efficient to take this and put it into this calculation, then make a whole separate variable just to do that with. Modern computers are more able to run some extra calculations rather than having extra variables sitting around. So if you do everything with just the one, and it's like, okay, we're using wet here, and then also dry is the inverse of wet, it's 1 minus wet, we can just do that math, and it'll probably run faster than making a whole separate variable called dry to carry that and having to pass it into the processor to use. So we got that going on, but we're probably not using this, so we're going to cut that out. And we're going to cut gain control out because that's what it started with. And now we have even less. So here's where our actual code is. Oh, look, this is a weird little program. I've somehow generated this. Oh my God, what was I thinking? I don't know what I was thinking, but we're going to find out, won't we? Because we're going to make this do a thing. So firstly, let's make some sense of this. Well, no, firstly, let's copy it over, then we'll make some sense of it. I've already copied this. So we're going to copy all of this right up to the end. It'll take a while to scroll because this is an antique computer that I'm doing this on. But that's apparently how this was done. And I have no idea why. But we'll find out, because we'll find out what it sounds like, what this crazy thing sounds like. And there's our output in the bottom here. Dest P equals input sample. That exists in the one that I'm about to be using, so what I can do is just copy this, close it, and then this is all I'm going to need. And I'll put it in front of this wet dry stuff in case we end up using that, because it's the possibility that I'll end up expanding it and adding more controls. But for now, paste in here and let's see what we get. It's definitely pretty weird looking. So let's see. That's also refactoring. It's moving that bracket around so that it makes a little more visual sense as to what we're doing with it. And probably if I compile this, it'll run, but I can find out. One thing I might find out is that it's still talking about slider. So that has to go away. We deleted all that stuff. We didn't delete this line. Boop, and now we have. We'll build that. It is not using dry sample. And comment that out while I'm at it. Now this says no issues. Isn't it nice having a build with no issues? Our issues come when we try to figure out what the heck it is doing. So what we've got is frame number is counting. It is counting sample by sample. It's like a pulse wave, because it says in my comment, because I have some comments. Oh, sure. I would like me to make the chat window a little smaller. I believe I can do that. We're not using chat very actively, so you can see a little bit more now. Scooch this over. So what are we doing with this? We are, firstly, we got this stuff kicking. Well, first of all, want to listen to it and then try to figure out how it did that. Oh, I just made a breakpoint. Don't need that. I don't tend to use those. That's a thing that you can do, but I have never had much patience with it. No overall scaling. Build once more. Go to release, and hey, we've got a component. And that was the old version that we don't need to look at, so we're going to open a track. This is the album that I have a gajillion copies of, because this is back when I made a CD. And it sounds like this. I don't have a way to pipe this through into the music, so you're stuck with it. But we can turn on Nikola, and it'll be terrible. But it'll be this particular kind of terrible. I think this was a April Fool's plugin. What do we got? It's actually not that far off from the Tesla coil. Alrighty. That's going to be popular with my audiophile listeners. Strangely, you can hear the bass in here. So now let's figure out, how does it do that? And yeah, this sounds completely terrible, but it sounds completely terrible anyway. And the weird part is how you can actually hear the bass through it. It's meant to sound like a audio Tesla coil. An audio Tesla coil makes all of its sounds by firing off bolts of lightning at audio rates. And yeah, this is actually better than I remembered, while still being completely horrible. Let's have some more fun. What else can we do? Like if we have a sine, it just does this. And if we apply that and look at it, it's making this shape. That is apparently what happens when every cycle happens, is it makes this little zap. I probably got it from some recording of a Tesla coil or something. I'm not really quite sure. I think it's firing that off, and the voltage has to do with how big it is. And I need to remember not to save that. And lastly, let's play with it on a drum sound. This being Nikola, as promised. Okay, that's weird. Does it shut up when it gets quiet? Let's find out. No, it's monstrous at all times. Or at least when you crank up the coil voltage. And we seem to have something in here. Raw sound is like this. Yeah, it's definitely your black metal mix plugin. So how does it do that? Let's find out. Back to looking at the code. We are not going to worry about scaling it, I think, because it'd be more complicated trying to fit in sample rate stuff. So let's delete this. This is one of those ones where I'm not really inclined to try to make it be all sophisticated so much as just get it working. And I'm of two minds as to whether wet dry is good. So tell me in chat if you think it should have wet dry. Oh, no. See, we're about to dig into it and find out how it does what it does. This is part of how you do the programmings. This part up here is simply stopping the input signal from being too small and going into denormalized numbers. That's a thing that can improve performance on some CPUs. So here's the thing. We don't have to define bridge rectifier up there. This is a thing I picked up from my brother when I was hanging out with him. You can define stuff where it's used. So we start off with this, and then we make this other thing, bridge rectifier here, which is just my it could be any name. It's what I used back in the day for sort of calculating stuff with, because I was using it in density to keep hold of a value, and I considered it to be like a bridge rectifier in electric circuitry. Okay, 1 vote for wet dry. You can see how fast it is to add that. And if bridge rectifier, i.e. the absolute value, see it says fabs input sample, so it's always positive. If it's a negative value on the input sample, it'll be flipped over to become positive again. That's actually the same process as in my Green Ringer plugin, where it just makes it the entire signal positive. It rectifies it, which is probably why I called it bridge rectifier, is it does make sense. That's what a bridge rectifier does, is it causes the negative swings to become positive swings and the positive swings to stay positive swings. So it's actually exactly the right word for it. If bridge rectifier is larger than out level, the out level equals bridge rectifier. So we're chasing something. Else, out level is out level times 31 plus bridge rectifier divided by 32. So do you see how that works? This can sit in a larger place too. This stuff can live as a separate little zone. It's within these brackets. So if the sample that you're sending is hotter and louder than what this number is doing, it's like a compressor. It brings the number up to whatever that is. Otherwise, it goes back down again, and here's how. Is if the bridge rectifier is not larger than out level, it must be smaller, down to close to 0 to maybe 0, because it's the absolute value, so it's always going to be a positive number. But if the sound is not loud, it'll be quiet and closer to 0. So if the bridge rectifier is not higher than out level, here's what we're doing. So that's the sequence of things we're doing. Now, to have it work as actual numbers and things, I have to have these semicolons at the end because it's C, it's the C programming language. But here's the things we're doing. And can you see why? This is a low-pass filter. It's not a low-pass filter on the audio so much as it is chasing the loudness and keeping par with how loud things could get. And then it's cutting it back when it's not being that loud. So if this input sample level, which is always positive, it's been flipped so that it's always positive, is hotter than the level that we're chasing. And I'm going through this in such detail simply because people are talking about how do I start programming, how do I do stuff. This is what it is sorting out these details, these things that you're doing. And sometimes I like to make it fairly simple. And we haven't even gotten into the how the supplies, but we can say, and in fact I have said in comment, set up envelope for handling quieter stuff if desired. So if this is apparently for quieter stuff, this makes things be quieter, and it's making a out level, and interestingly, and you see what it does is when, maybe I should, would it help if I got paper for this? I mean, you're looking at the actual code and stuff, but we're basically taking this number, like what if you did this, right? Out level times 32, and then out level divided by 32. We get the same one back. The same out level comes back. Now we had it as out level is 31 is how it worked. That's going to make it get smaller and smaller as long as that's happening. But we also have this other thing here. Out level plus bridge rectifier, which is always positive. And if bridge rectifier is louder than out level, then it just out level becomes bridge rectifier. So it's like it'll go up to the maximum loudness, or whatever it chooses to be. And then when it drops back, it starts dropping back. Now, the interesting thing about this, I do need a piece of paper to do this. Give me a second. Oh, I got paper. I need a marker. Where's my damn marker? Here it is. Okay, I'm going to show you why it's doing this. Let's say, and I got to go to my actual camera for this. Let's say we've got this. Let's say it's like out level times 4 or times 3 plus bridge rectifier divided by 4. So if it was all the same volume, what's going to happen is you take this level that's like up at here, the level that you're trying to deal with is going to be this proportion. We're starting with the level, multiplying it out, adding what the bridge rectifier number is, and then dividing it down again. So we start with this level, multiply it, divide it, and we end with like this level. It gets quieter. It falls off. It's like a decay function. But we're also adding bridge rectifier. Now, what happens, I ask you, if we do outlevel equals outlevel times 31, outlevel equals outlevel plus bridge rectifier, which is not 0, which is close to being as loud as outlevel, but isn't. Because if it's louder, it just resets, it bumps up the volume. It's like a compressor. If it is close to being as loud, we've got like these values here, and then it's close to being as loud. We've multiplied it up 1, 2, 3, or in this case 31, and added an additional one on the end and divided it back down. That means that what starts out at here turns down if bridge rectifier or the input loudness is not as quiet as 0, rather than just falling off, rather than just having the amplitude fall off when it's no longer as loud, it'll fall off very slowly. It will fall off to the amount that the bridge rectifier is a large number. And if it was halfway to 0, it would end up about here. You'd have your input number, which was full volume, multiply it by 3, and add bridge rectifier, which is halfway, and then divide by 4. And again, it cuts back less. I'm not sure how much sense that's making, but I'll go back to the code now. And this is the kind of stuff you do when you're trying to make the output level not just fall back at maximum speed anytime that it's not being pushed up. This is something that you could do in a compressor as well. I'm not sure if I've done it with a compressor, but I could try. It's actually acting kind of like a compressor in this context. So what we've got here is this, and then what I had was a series of parentheses like this combines that into a single statement. Level times 31 plus bridge rectifier, and if I add more parentheses, let's find it. There we go. There we go. I found it. Right place. We make the original statement that I had, which is a more complicated looking, but it's still basically the same thing. Interestingly, with this stuff, when there's only one statement, you can leave out these brackets, but that's only because it's a single statement. If I had that at multiple statements with multiple semicolons at the end, I would be forced to put the brackets in, because the brackets set it apart as a single lump of code that's handled by the else. Kind of like this. This is what brackets mean. And you notice that it flashed. That's showing you what this area contains. Or if I put it all in the same level, it'll do the same thing. It's showing you what that area contains. Else, everything that is inside this little zone with the flashing yellow thingy. And since it's only a single statement with only a single semicolon on it, I can leave that out if I want. Just glancing over the chat. So another thing that's happening is we've got frame number. Remember how we had this, and this is persistent across buffers? And okay, that's weird. What do we have here? Oh, okay. I have a bug. Let's see what this does. I've defined out level in two places. There's one that's stored across buffers, and there's one inside this place, which is within each buffer. Each time it says process, and it gives you this pile of samples to do, and you do them one after another, while in simple frames minus minus is still larger than 0. It counts through them. But I've defined out level here and here. So that's a mistake. Let's quickly see what happens if I delete that and build, which I think it will. And having done that, now we need to hear what it sounds like, because we just changed something that's tied to how the sample rate works. Well, how the buffer works. So again, we'll fire up this track. Go to this piece of it, because it's kind of a mellow thing that interacts with the sound. And now as Nikola sounds like this. And you know what I think this is doing? I bet you what's happening here is it's doing this and generating its sound this way. It's a little smoother now because it's not crashing, it's not resetting the buffer all the time. But the raw sound is like this. And when we set coil voltage to 0, it's using that thing where it's multiplying by 31 and dividing by 32 and making a sort of envelope, and it's using that to turn it down. So let's continue fooling with this. We've got out level. We don't need to reset it each time. So that makes sense to not be resetting that way. It'll probably sound better with bass, but this is a laptop, so you can't have any. Float coil equals 0. Well, here we have a place where we can define this up here. And we've moved it closer to where we're using it, much like here. Here's our thing where we're chasing the value of this and using a bridge rectified output to do it. We're adding 1 to frame number, so it kind of just keeps on going. And we're defining coil as 0. And if input sample is larger than 0, if was negative. Want to unpack this one while we're at it? This is a little pile of stuff. One thing we can do is take away these brackets because we only have one thing as part of the else. But we have a whole bunch of things as part of this. So what have we got here? If input sample is larger than 0, and also, tell you what, let's the arrangement of these brackets sometimes matters. So, if input sample is larger than 0, was negative is always false. So we can skip this stuff because these brackets don't do anything. These brackets do. So what we've got here is kind of like order of operations in a sense. We got two statements. And what this bit of stuff does is, if input sample is larger than 0, and if was negative equals true, because that's what this means. If you go if was negative, it's a Boolean. So if it's true, it'll answer yes and then do whatever you say. If it is not true, it will answer no and not do what you say. So if was negative equals true is the same as if was negative. And you'll notice that it says frame number equals 0. We've been counting up this number, frame number, this entire time. But if we are crossing from one point to the other, we're starting out here in the tiny vision at the bottom of the screen. We're starting out here in negative, and at the point that we cross over and it's suddenly positive, then was negative is true, but input sample is larger than 0. At that point, you tell frame number to be 0 and you reset it and start it over. And having done that, you tell was negative to be false. If input sample is not larger than 0, which is this else, then was negative equals true. And we're not looking at that other part. So this bit in here must have some brackets because it has more than one statement. However, if I want to be funky, I can squish it together like this. I believe I had it like this. And that's going to do the same thing. It just takes up less space on the screen. You can see it a little bit more clearly that way, even though normally it's not good C practice to squish stuff up horizontally like that. But everything that I have inside this bracket, remember the bracket thing flashes when you go across the end one? Everything within the space here is what happens when input sample is larger than 0. First, it finds out whether it needs to set frame number to 0, and then it always sets was negative to false. So it's going to do that once. The audio units use float 32 and float 64. You can see up here, this is part of the audio unit framework, where your source and input and output numbers. I think I found that it also did float 64. It might be Apple's way of using a form of audio unit related number that doesn't do denormalization or something. I'm not really sure. In any case, it's defining a number much like I do with the FPD number, where you're specifying the bandwidth of it, how many bits make it up. And float32 is part of the Apple spec. It doesn't show up in the VST, but VST has its own form of numbers. So basically I try to see also up here, float32, uint32. These have been defined either in the Apple math code or the audio unit code to have a specific meaning. So we're just using the format that Apple intends, or that Apple started off with. You can also look up here, actually not up there, but in other places like maybe not. Well, it does have things like CF string ref that are defined as something. And yeah, virtual float64. So these parameters expect this result. They expect to get a float64 variable back. So you could say, you could return a double. It wouldn't necessarily mean the same thing, probably would, but I stick to the formulation that the framework wants. I stick to the style that the template already has, in hopes it will behave properly for me. Some things like, AU base or whatever are very much part of the framework. Like, you're not going to be changing component result with something like int. It's definitely going to need to return component result, and component result is probably a little structure of some kind. But the details of that aren't as much of a concern for me. So, we've been counting through a frame number. And here's how that works, is if frame number is larger than 0, but frame number is less than 469, remember it keeps counting up. Whenever it is not actually, when the input sample crosses 0, it starts this at 0, and it counts up. But it keeps going forever, unless it's restarted again. So we got coil equals 0. We're apparently just storing it in this. And I can tell you what that is. That is a little, it's like a convolution kernel. I don't know why I have it quite this way, because it's breaking after every single case. I guess it was just convenient to make. There's no special reason that I couldn't call just input sample. However, I will look it up and find out. It's making input sample immediately be coil, so we can refactor this and not even have this variable there at all. But what we're doing is, as you can see, every time the audio crosses 0, it's restarting here. It is an IR. That's exactly what it is. In fact, I can show you what the IR is. But let's I'll open this thing called sine bases and copy this. I'm just making a document with this so it can be disposable. This is a very slow frequency. Can't even hear it. It's like 20 hertz or something, but it's part of my testing procedures. But if we run Nikola on it, now we can hear it. And it seems the coil voltage seems to control how loud it is, so we'll turn it up good and loud. And I will show you. Actually, I think we're clipping slightly. Yeah, we are definitely clipping slightly. So let's undo that. Redo Nikola and cut it back. And there we have, that is our 500 sample audio. And what this plugin does is kind of like this. It's firing off this impulse response every time the signal passes 0. So it's trying to chase the frequency. But rather than overlaying each new impulse response, it's just resetting it. So let's see now. Scooch it like here. You heard it going da 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 da. But if I dragged it like this, that's going to loop this area. And that's what Nikola would sound like on that frequency. Or this is what it would sound like at a 500. And rather than play the end of this, like this, if you're crossing over more rapidly than that, it's going to take whatever piece it has and it's always starting here and going as far as it can. Like if it's a bass frequency, it'll go out to here. If it's a high frequency, it'll reset it in the middle. It'll reset it over here. Like for instance, if it was here, and that's how Nikola works. So we can quit out of here and go back and look at the code. What we can do is get rid of this coil because there's no real purpose for it being there. So this version of Xcode has a thing in it called Edit All in Scope. And it's updating all of those, so it's being very slow. Look at it grinding away. And my real computer could do this faster, but this is an antique. It's so that these plugins can all run on pretty much any software out there. So we're going to wait for it to character by character update everything. And then once we're finished doing that, we can deselect it and I'm assuming this is the thing I can do. So if the frame number is larger than 0 but less than 469, we do this. This is also where the sound is loudest. So one thing we could do to fool with the tone of it is I can make it so that it will be brighter for higher frequency sounds by starting in the middle of one of these rather than sort of warming up to it. You'll see that at 0, it's starting the input sample at 0. But I could start the input sample way hotter, like up here at 16. And it'll still continue to go forwards until it is larger than 469. And this is the impulse response that it produces. I think I must have got that off of a recording of a Tesla coil, that there was a spit, a pop in there. and I was able to isolate one zap to the best of my ability. And then since we are no longer doing that, input sample times equal 1.0 minus envelope times 1.0 minus out level. So this is basically scaling the envelope, the output of it, to whatever the envelope is. And that's the last thing in the plugin. So let's do that experiment that we were talking about. Like I said, if input sample is larger than 0, we're doing a 0 cross. So what point do we start this impulse response? Well, here we started at 0. And as I showed you, we'll fire up DrumRig and I'll briefly demonstrate. So this is scaling it. Like if I don't do it, everything is always at full crank and there's no envelope. So this is using the full dynamics of it. We could also want to make it sound more resonant. This is dying away rather fast. You can see what I'm doing here is we're still doing the something times large number plus bridge rectifier divided by one larger of a number. That's going to make it fall back more slowly. And we'll build it, throw it in here, and hear what it sounds like. This is kind of how this works. Back to our drum rig. And you will hear that now it'll sound different. Not very different. Sounds kind of good though. I'm liking the direction that's going. This is the fully clamped version. Although I wouldn't mind it shutting the heck up in the middle of this. I like how obnoxious it is. But it doesn't silence itself when it's quiet. So maybe we'll do that. We'll finish up some of these things and then I can be finished with it for the day. And we'll post this as a plugin. If you really want this next week, you can have it. We'll see. Just for fun, we're going to randomly add 9 to the thing. So now it's huge. So now this is going to fall away really, really slowly. There's no reason for the 9 other than that just makes it be a very large number. And it's still one different, it's still one apart. So if we have slowed down the decay of that envelope that much, what we're going to get is, okay, we'll finish it up today and post it. I'll have the VST made of it. That's a much more boring process. So now it's slowing down much more slowly. You know something? We could tie this to coil voltage. We could use coil voltage for this parameter rather than what we were doing. How's that sound? Because, like, I'm not sure how useful this is. But if we literally replace it with this process, here's what we're going to do. Never mind what coil voltage used to do. We're ignoring that. That's gone. Env is what that did. And env, here, let me get another notepad. Another note for writing this stuff down, if needed, is 1 minus power get parameter param1. So that's going to be a small number unless you crank it up. So it's going to be 1 unless you crank it up to a point it gets smaller. So the large number here we're going to rename this to decay. We're going to well, let's see now. Env is going to be a positive number, and it's higher when it gets larger, and it's smaller when it gets quieter. So technically, all of this can be done with input sample times equal env. So we're no longer using the parameter for that. And if I still have it working, let's see if this builds. Env was not declared in this scope. Where do we have it? Oh, we didn't define it. That's because we want to use out level, not env. I had that backwards. I deleted the wrong thing. So put sample times equals out level. Never mind env. We don't want env. It's gone. Now it succeeds, although it's not using this variable. So what we'll have now, over here, put this in. Modern versions of macOS, you have to reboot every time you do this. Thankfully, this is Snow Leopard, so I can do this all day long, and have done many times. What we have now is what we told it to do previously, but this doesn't do anything now. And remember, we had a small number, and it was tighter. And then we had a large number, and now it's just this roaring mass of explosion. And sounds much louder. So, here we go. Decay equals 1.0 minus power. Larger is longer, shorter is quieter for what we're doing. So we don't need this 1.0 minus. This makes us have a get parameter, a kparam1 is 0 to 1. In VSTs, it's always 0 to 1. In audio units, you can tell it to be whatever you want. Often I'll leave it at 0 to 1. And power, this to the power of 2 means it acts exponential. It changes the curve. If I didn't have that pow minus 2 in there, then the number will linearly increase. I can also have it be pow comma 3 or pow comma 4 to have it be an increasingly exponential curve, kind of like linear is like this. Exponential or power is more like that. And then as you keep doing it, you wind up getting to where most of the control does really tiny changes and then huge big changes at the very end. That's if you increase this number in the POW calculation here. But we're doing it from get parameter POW1. Now notice how this is inside. It's doing the same thing. It's lighting up. It's inside the POW, so it's returning a number which is going to be 0 to 1. We can just change that. We can multiply it by something. So we're defining it as decay and multiply it by, well, 9,000 is pretty big. We could get sillier though. I'm going to guess we're going to do a power of 3 first off. And then rather than 9,000, 10,000. 32767 for no particular reason. It happens to be a like 16 bits is that many numbers. It could be anything really. And then one other thing, we're going to use it here. Actually, we're okay with having it be a 0, and I'll tell you why, because this is the thing. This will give us a 0. Decay POW get parameter param1, that can be 0. So 0 times 0 times 0 is still 0. If we multiply it by this big number and it's 0, then we're still going to get a 0. So what we get then is, this is where that gets used. We don't want to divide by this number, but we're not going to be dividing by this number exactly. We're going to multiply by this, add the thing that we're working with, and then divide by that plus 1. And that means it will not crash or die if we get it wrong. So if we have a very small number, I'm thinking maybe I'm going to be wanting to make it an even higher power. Also, one thing to point out about this, we're doing this calculation here, but this says while and sample frames here. If we've got like, a buffer of 128 frames, a buffer of 128 samples, this is how you set your latency. Your latency determines how much this is. It's going to do this 256 times or 128 times or whatever before going on to the next channel. That's how the latency works. That's why you can do more with a larger buffer setting and have lower latency with a smaller buffer setting, but it starts to kill your computer. It's because it's switching around all the time and it's doing this stuff up here more often. The stuff within the buffer is all in here and it gets to skip this stuff. That also means that if you're controlling this, you're going to get zipper noise if you're making changes in a parameter that's in here that's not getting updated every sample. But for now, we're going to build this and it will succeed because we did it right. Or at least we'll find out, but I'm willing to bet it will. And we're going to bring up the same drums we were listening to before. Fire up Nikola. It is still labeled coil voltage, and now what we get, a very quiet sound. That we can expand the delay of it some. And as we increase the coil voltage, it starts acting like it's reverb, although it's really not. And what's happening here is it's resetting the sample every time it goes, but it's scaling it based on our envelope. So it's doing the same thing it used to do when we cranked it way up, just full blast all the time. And that full blast is pretty much always happening, although I'll show you a way to make it stop. This will make it stop. I just silence that. I need to remember not to save or I'll lose that bit of the audio. But when we do this, it's no longer crossing. And so you get silence. So the only way that horrible noise keeps constantly rehappening is if the audio is re-triggering the zero crossing. And it doesn't matter how quietly it's doing it, only that it's doing it. And we'll see it kick in again. Like over here is another part that looks silent, but it's not. There's background noise in there. So it fades away. And it retains whatever noise is part of whatever character is part of the noise. Don't save. So that's how we get that. Does that seem like enough decay, or should we add more? It's a pretty good amount of decay, and I think that the curve of the control is working good. This 4 number is working pretty well. And 32767 doesn't actually mean anything, but it's fine. And there was one more thing I was going to describe and explain. Namely, what happens if we are not starting highs? That is a control for decay. Literally, the voltage control actually means decay. It's part of what you get with a weird plugin like this. So, you'll notice that we have this drumming noise, but we're not hearing the hats very much. We're kind of hearing them. And that's because this sample is getting restarted at 0. It only scales up so fast. We can do something to change that. We can make it start at frame number 16. Frame number 16 is pretty much full crank and about to fall off very rapidly. Or we could just do 13. No, let's do 16. That'll accentuate it a little more. Can you guess what's going to happen when I do this? Actually, that could be a control 2. We can put a knob on that. But for now, quickly build this. Drag into the folder. Whip out our little drum rig. What you're going to hear now is, now you can hear the hat. Why? Because the sample starts at a loud sound rather than starting at a silence. So what I'm wondering is whether maybe I can tie it into coil voltage and have an interesting effect there. See, if we have it at this high voltage, the high frequency stuff sounds kind of stupid. When we have it real quiet, the high frequency sounds better. It sounds a little more natural. So what I'm thinking here is we want this number to be a variation off of this number. And we can calculate that separately too. Highest boost. We'll call it that. And that is 16 being the one that we started with, minus I don't actually need all those parentheses in there. However, I could do we'll see whether the power function, no, actually I think I want that one to be linear. My instinct is telling me that this one wants to be linear. Oh, I did need the parentheses. I'll tell you why. Because we want to make this be an integer number times 16. So it's always going to be 0 to 1. If it is at 0, then it's 16 minus 0. If it is all the way cranked up to 1, it is 16 minus 1 times 16, namely 16 minus 16, namely 0. And what that does is, frame number is set to this. So when we have it quiet, it's going to start out at the place where you get the highs, and the farther we crank it, and we can adjust the curve a little bit, the farther we crank it, the more it's going to start losing those highs and sounding big and huge and overbearing. And we'll build that. I bet it will build just fine, sure enough. Components. And we'll go back to drum rig. That being a reasonable way of checking this out. I'll show you something else before we go, which we should do pretty soon because I'm running over time, but whatever. We hear our high frequencies, then overcrank. And there you have it. Now what I'm wondering is, we have our highs here. If we go to the middle, do you want it to be pushed more towards the highs this way? Because I'll tell you how we do that. I think we can get away with a little more highs here. If you can hear, we're losing it. Highs, and then they're going away a little too fast. And this is where it should be getting away. So here's what we do. We go back into here and integer form of the power. Oh no, wait, hang on. It doesn't go there. It goes here. power of get parameter parameter1. Close that in parentheses because it's part of the power statement, and it takes a comma, and it takes a number like 2 for the square of it, or 3 for the cube of it, and this one is all the way to 4, but I think this one's probably going to be fine just at 2. But we'll see. We can try 2 and we can try 3. Back to our drums. And we're going to see where it sits now on the scan of the parameter, because it should work in a natural fashion. Okay, that still feels bright. So the question becomes, should it be bright here? I'm going to try that 3. Get parameter parameter1 comma 3. We'll build it. And we'll test it. I suspect this is going to be the one. That's some high voltage right there. Oh, you know what? We have not had that on this entire time. Oh, Easel Weasel, I'm sorry. It's been some time since I've had the editor up. Well, it's about time for me to turn off and go rest. But here's what we got. For one final change, I think I can smooth this out a little more. So 3 and 2, both of these get scaled down a little bit so that they sustain a little more towards the middle of the range. Build it. Plug it into components. Use it immediately, since this is not a modern Mac OS. This is Snow Leopard, so it can use plugins immediately. And That feels like the right range. Alrighty. One more thing. We're going to fire up Dragons before I go, and you can hear what it sounds like on Music, which it was always designed to sort of kind of do. This is kind of what it started out like. They're pretty nasty. Remember, it's a Tesla coil, so it doesn't do bass. Here's a techno track. Sounds like this. This is what it's like set on fire with Nikola. Alrighty. So I think that's enough fun for now. On my own time, I'm going to throw the wet dry on there because it seems as if people will enjoy that. And I will port it to VST. And if you like, you can have it next week. It's been fun. I gotta run. So I will talk to you folks later. Bye-bye.